Welcome to our latest webinar at Austin Data Labs, all about data science and the food supply chain. We have three fantastic panelists here for you today: Sushil Verma, Evan Davidson, and Simon Drake. Sushil is our president and CTO. Over the last 20 years, he's invented multiple data-driven applications in the areas of demand management, pricing, supply chain, healthcare, and machine learning. He holds multiple patents, and he graduated from the University of Berkeley, California, Berkeley, with a PhD in operations research. Evan is our principal data scientist and has been working in the field of optimization data science for the past 15 years, prototyping, building, and implementing pricing and revenue management models in a variety of industries: consumer goods, retail, import and export logistics, and food production, to name a few. He graduated from the Massachusetts Institute of Technology with degrees in mathematics and management, and later from UC Berkeley as well, with a PhD in industrial engineering and operations research. Simon is our COO. He brings us 15 years of experience designing and implementing data-driven revenue management models in retail, manufacturing, and commodity agriculture, and has a degree in theoretical physics from York University in England. My name is Leslie Poston. I'm the CMO at Austin Data Labs, and I'll be your host for today. The first question we're going to kick off for this 30-minute webinar, followed by some Q&A, is for me to ask Sushil, can you talk briefly about how we think about data science and AI here at Austin Data Labs?
Well, thanks, Leslie. As you know, data science is such a big discipline now. It encapsulates so much. So for us, what it means is, I'll mention three things. Number one, it's a vehicle for innovation for us. So at Austin Data Labs, as the name indicates, we take innovation very seriously. And we believe that enterprise solutions have been sort of stuck into the sort of need to standardize a little bit for far too long. And there is a real need for innovation. And when it comes to data applications, basically using data to make better business decisions, it becomes even more important. Data science naturally requires a different approach to building software. So I'll give you an example. At a major food manufacturer, they were having trouble using their ERP system to deploy their products in a nationwide network sort of correctly. And they tried to use the ERP system itself. They tried different methods, but they needed to think out of the box. So we have come up with a completely different approach to deploying their products using data science. So that's an example of the kind of innovation we can do with data science. Second way we sort of think about data science is that you need to choose the right kind of data science for the problem. So data science is so many different things. So you have Bayesian inferencing, you have risk optimization, you have deep learning in AI, and so on and so forth. So enterprise CIOs and CTOs are being bombarded with so many different kinds of buzzwords these days. So it's very difficult for them to figure out, do you start with a tool and look for an application, or vice versa, and so on. So we have built a team of experts so that we can do that well. We are really good at mapping the right data science to the right application. For example, at a major fast food retailer, we found that a traditional approach wasn't really working well. So the problem they were trying to solve was to project revenue in each of their stores. And traditional way of thinking about this, it uses data science, but traditional way of thinking about this is, hey, let's use price elasticities and their promotion calendars and match the two things and try to project the revenue. And that works decently, but this is place where AI actually is a better tool. So we are using AI there to not only look at the pricing and the promotions, but also look at what else is going on in that store. Are they doing something differently at that store? For example, they may have added some new parking, or demographics in that area is shifting. So that could have a big impact on revenue as well. So whenever we have lots of different variables, AI starts to become lot more relevant. So that's an example of how we try to match the right tool. And the third thing I want to mention is at Austin Data Labs, we deliver end-to-end business applications where data science is at its core. We don't just deliver a data science model. So it's very important for us that it works in real life, the data science we're building. So that's at the heart of every customer and every application we have built so far. So those are some of the ways we think about data science, at least from my perspective. So let me ask Evan how he thinks about it.
Yeah, no, I think that's a very good summary of kind of the way we think about it. I want to expand upon your second point around kind of the art of data science, because like you said, there are so many different ways to think about optimization, to think about AI, to think about how to take a customer's data and apply the right set of algorithms and come up with potential solutions. What I see as my job as the data scientist and our data scientist team is to find the right set and the right granularity of data to be sure that we're producing both reliable and rich optimization. So it's all about kind of understanding the problem itself, really having someone or a set of people who know the industries well enough to be able to ask the right questions, to be able to understand this set of constraints versus that set of constraints, in terms of how to properly, I would say, how to properly set things up in a way that run reasonably, run quickly, and get you an optimal solution that works for each given customer. So it's really about the art, I think, about the human element in a way, because there is no one size fits all. There is no one standard. Every company is different. Every company has its own issues, and we have to be cognizant of that. So I think Simon would be a great person to talk about those differences.
Yeah, it's always interesting. I work more closely kind of with the business owners and the people kind of on a day-to-day trying to solve problems in absence of data science to begin with. And so we'll often start talking with a company where they've got a process which is very manual, it's time consuming, they try and apply some rules, and they run into problems every now and again because things are just a little bit outside of their intuition. These odd occurrences occur. They may only occur 1 in 1,000 times, but there's lots of different things that can happen that can go wrong. And so they're running into these problems. They realize that they're coming up with a schedule or a plan, and they know it's not quite right, but the focus is on just getting something that will work and move product from point A to point B, or create a production plan that meets customer orders most of the time. And once a month or so, they'll run into a problem. Things won't go quite right. They know they're leaving value on the table. And they talk with us about how can we put something in place that recognizes the constraints that they're trying to handle, gives them results that they can really use in the business, and will drive them forward. And so it's a really interesting task of trying to condense these rules down into something that's then meaningful and usable by the data science team to come back and actually generate recommendations. And to talk to, I mean, it really is about working with people like Sushil and Evan is great, because you'll bring a problem to them and they'll think through, well, what's the right way to go about solving it? And the real end goal is, how do we come up with something that really drives change in the business? And I think it's enjoyable for me to get to be a part of that. I think one of the interesting pieces, just maybe a thing to drill into a bit, is when you're looking at a supply chain problem, it really spans everything from very tactical executional problems. So if we talk about the example Sushil mentioned, like the logistics of distributing products across the nation, you've got very tactical problems like what pallets do you load on a truck or on a rail car, and you have to make sure it doesn't weigh out or pack out, and you've got to follow rules around how do you actually go about loading a vehicle, all the way to over a long period of time, over a quarter horizon or a 1 year horizon, what's the right network to have, or what's the right number of vehicles to be planning to use. And so working on constructing a model that works both tactically and gives strategic guidance is an interesting challenge. I don't know whether Evan, you want to talk a little bit about that, because I think that's often where I think other approaches will fall down, because you can focus on one area or the other, and if they don't connect together, you've got a disjointed process.
Yeah, absolutely. I mean, I think that the questions that you ask, you could potentially make those tactical decisions, but try to build out a model that tries to solve that problem over the course of a year. And at the very in that way, it would be simple to to build the problem. I'm running the same thing over and over again every day for a year, but the issue there is that you run into runtime issues. I don't want to be solving this tactical problem over the course of a year. So in terms of setting up the problem, it's easier. But in terms of actually solving it, it's just totally unfeasible. And the results out 6 months from now are not going to be usable. So then the question comes, where is that dividing line? Where is that that line between building something for the short term, building something for the long term, and how do you stitch those things together? And it's really kind of those points at which you're stitching those things together that are interesting, because we need to make sure that we're solving both problems in a way that is will give useful business information. I think that as long as if we solve the problem in a way that takes too long, that's not helpful. If you solve the problem in a way that isn't complex enough to actually solve the short-term problem, then we're not providing value. But in terms of the blending, how do we decide that dividing line? How do we, stitch those things together? And I think that, kind of understanding every client is different, and that understanding where those dividing points are, and how to best, again, stitch them together. For example, one client we're working with right now, we have both a scheduling model and a long-term supply production demand matching model. And so we're only doing the scheduling for the first couple weeks, and then from then on, we're doing this more longer-term model. But we need to make sure that the results that come out of the scheduling model fit in this longer-term model. And so we need to make sure that those results, again, they match up, that we're not telling the scheduling people to do one thing and the overall tactical or the overall strategic team to do a different thing. And so we take those things into account when we're building out these different sets of models for any given customer, to make sure that we're solving their problem in a way that is both reasonable to solve in a quick manner, but also is usable over both sets of time horizons. Sushil, would you have any more to add to that?
Yeah, I think we can sort of condense this into sort of a couple of principles, which we informally follow here. And the big one is never boil the ocean. I mean, never try to boil the ocean. It will never work. And sort of second principle associated with that is, even though it's science, it should be explainable. You should be able to explain it to someone who doesn't understand data science otherwise, but understands how their business works. So if you're doing it right, you should be able to explain the science to anyone. So that's another principle we sort of follow. And this is not acting in vacuum. I think that there is like over 50 years of research in supply chain management now, and a lot of that is hard science. It's often as hard as physics is, and people have learned that keeping things simple is important. It should be as simple as the problem requires, but no simpler. And it's the same principle a lot of physicists follow. There are reasons why the best equations in physics are the simplest ones. You can write them on a T-shirt. So it's the same idea, very different sort of domain, but we try to follow sort of the same principles. So going back to the logistics problem, so what this ended up, so these principles, when applied there, translated into us not trying to solve a single sort of model to give them the final deployment, but breaking the problem into different steps, each one producing something which can be verified and understood. So for example, the very first problem is like, what's your inventory levels you want to go for, and what's the service level you want to go for, because that drives the rest of the decisions. And if you can break that separately and explain that and agree on it, then the next step becomes that much easier. And then instead of immediately diving into the trucks and rails, we needed to do a rough cut planning. So rough cut planning requires a different approach. The idea is to not get all the details 100% right, but make sure your overall transportation plan is good and is then verified. And then the last step happens, which is, okay, now we agree on that. Let's translate this into a actual executable set of decisions. So that's how it's sort of applied. When applied, these principles translate into actual decisions.
Yeah. I think the interesting thing, all of us really get a kick out of seeing these models. It starts off as a concept, and it's equations, and it seems a little bit detached from reality. But then I think we all get a kick out of actually seeing people in their day-to-day business using them, and realizing that trucks are being scheduled, plants are being planned, based on these theoretical models. It actually translates into actionable results that change the way a company's run. I think that's the end goal, and it's interesting. We want to keep things simple, but the reason why we end up applying data science is because the real world is pretty complex, and it is pretty amazing when you can take something that people have been they've spent 20 years scheduling a rail car or scheduling a plant, and they've got all this information in their head, and they're going through a process that takes 3 or 4 hours, and they know that there's some things that they're not getting right. And then when you start to then have them using a system, and you get to the point where they're now doing that job in 20 minutes, and they feel that they're doing a better job, that there's a real, that's kind of a job well done, I think, from our point of view. And so that's always our goal. It's not, I think it's not to generate the most complex result or come up with the fanciest chart. It's how can we do something which encapsulates all this information, respects and recognizes that the job they're doing is tough and that they know a lot, and then come up with results that are actually usable.
Yeah, I think from my perspective, one of the things that gets me most excited is kind of taking that knowledge that's been gained by all these industry experts. Again, the schedulers, the planners. They have all of these rules in their head that they don't realize that they're following.
Yeah.
They've learned over time, over the course of their careers, that if I run it this way, it'll work better. If I run it that way, it'll work worse. And so, what excites me is to kind of talk to a lot of the people who've been doing these difficult jobs for years, and trying to tease out what what those rules are, what those innate, understood rules are, and translate them into math. Because once you can do that, once you can say, okay, this is what it really means, this is what you're really constraining against, this is what you're really valuing, what we can do is we can help them do their job. We can help them, say, I'm still following these rules, but I'm following them in a way that is more comprehensive. I don't have to sit and think about, these 10 things because that's all the time I have for it in a day. I have, I can solve 1,000 things in the course of 20 minutes. And then, if there are some outliers, they can go back and look at those. But in terms of, basically, translating those innate, the tribal knowledge, the learned knowledge that these people on the ground have, and translating that into a model and saying this is the starting point. This is where you've already started, and letting them run with it. That's what I find fascinating, is that how much we can help in that way too.
There are areas where I've seen that even seasoned business users, professionals, don't always know what data science is capable of. So I just want to talk about that a little bit. That's on the innovation side of things. For example, some of the latest in mathematical sciences, in AI, allows new things to be done, which don't even enter sort of the thinking process of some of the users out there. So we like to have those kind of conversations with our customers as well. Like, okay, for example, in some food production lines, there is a possibility now to collect more information about what's being packed, and quality sort of statistics can be collected, and that information can be used in various ways to gain new efficiencies and sort of improve productivities. So we are always looking out for such opportunities and be more proactive and letting our customers know that, hey, you are collecting this information, or you could collect this information, and that will open up new doors for avenues for gain. So that's another thing which we do. So it's not always about what they're already doing. Tell them, look, there are some additional things you can do now. And sometimes they naturally have an understanding of those things. Sometimes they don't. So you have to sort of look for the right match.
Yeah, and that I think that's a really good point. It's often the case that there's a process that's happening that can be improved, but sometimes you're really in a situation where a customer doesn't know what they don't know. A lot of times we'll work with people, and they'll be interested in learning from kind of what's outside, because they might have been in the same company for 10, 15 years, and been in industry, not necessarily in following data science articles or research. And sometimes they'll want to talk with us just to find out what's possible, and especially if they've been interacting with their interaction with data science came 20 years ago, when the field was, I think, first being really well applied into the manufacturing space, and things didn't go well, or a model took 24 hours to run or something like that, on hardware from 2000, and maybe not using similar techniques as now. And so they'll have in their mind, this isn't even possible. It'd be great if we could do this, but that's not possible. So we just get around it a different way. And I think that's an interesting discussion, where with the right open-mindedness on both sides, you can find out, well, what is possible, and we don't want to just go and apply theoretical things willy-nilly with a customer without understanding, can it actually be a benefit? But opening up and having that conversation, the art of the possible is very exciting. I mean, I think I know that Evan, you've been in situations before where there's that you'll either have good ideas that don't apply, or that there'll be questions about something someone would like to do, and sometimes you say that doesn't quite make sense, but here's another option.
Yeah, I mean, I think that in terms of examples like that where you have just as one example, there was an issue where we were dealing with basically a massive transportation network that basically it was kind of the tail end of the problem. And so, we'd solved the supply side of things, we'd solved the production side of things, but then to get to the, to get from the manufacturer to the plant to the final destination, there was this whole massive transportation network that was built out. And so, ideally, what you think is, I can model the this whole transportation network as part of this global model, this whole thing, and it turned out that it wasn't necessary. It wasn't really helpful to actually model the whole thing. You could just kind of basically you could do some early pre work to collapse this whole transportation network into start and end. You didn't have to worry about it going from this warehouse to that warehouse to this warehouse to that warehouse. There wasn't any major gain. There wasn't any major value in that. So can we actually do a little pre-work, do a little pre-processing to remove that whole optimization step? And how much value do we really lose by doing that? And so those kind of questions of like, how do we solve this in a reasonable way, quickly, and in a way that solves your problem? We're not going to boil the ocean to do it, and we want to, but we want to get you something that's usable, that's still valuable. And so I think that those kind of questions about understanding where the real gains are and where we can simplify are that's key. That's the whole key.
And sometimes that means helping the customers get ready with some data, especially when it's really cutting edge, innovative sort of solution. And we have done that, in some energy verticals, help customers identify with their initial data set where the gaps are. And if you could get additional data, what data they should collect. So that's sort of called, pre-AI. So that's sort of part of thinking process we can help customers go through as well.
Excellent. So we're coming up on time. 30 minutes always goes so quickly. So before we close out and take Q&A, I wanted to ask, is there a takeaway that each of you would give the audience today regarding data science in the food supply chain, that something they can use practically to get ready to work with a company like ours?
I would say the big takeaway is that a lot more is possible today with data science than it was let's say 10 years ago. So just understanding that better through some readings, conversations with us or anyone else would open up those avenues. Everything is being rethought. So let's say you talk about supply chain management, demand planning is being rethought of how it should be done or how it can be done. Cloud, internet, AI, all these things have impacted demand planning. Production planning is being rethought. People are thinking of bringing in risk into the calculations, and so on. So just be aware that a lot more is possible, and you don't have to stick to the older methods anymore.
And I think my takeaway would be that you also don't have to stick to the buzzwords. I think a lot of the buzzwords now are around AI and around deep learning and around things like that, and those tools are very useful in the right ways. We just have to have people to know how to use them, and you also need to make sure that those are the right tools to use. So there are so many different tools that are available to us, and understanding what level, how to properly, again, get to a point where we're not boiling the ocean, where we're not just deciding to use AI to use AI. We're choosing to do it because it's the right way to solve the problem. And making sure that those things are available, but there are a lot of other methods that are also available that and merging them together and figuring out how they fit together and into your particular business is the key, I think.
Yeah, I think it's interesting that a lot of what we were talking about is that building the bridge between the real world and the business problem, and then the mathematical world. And I think as you're thinking about how do you construct that, it's really important that the data science approach takes into account that there is a need to truly understand the business in the first place, which is why we keep talking about our customers a lot and understanding their exact situation. Because in order to model something well and not boil the ocean and not just treat it as a mathematical exercise, you really need to understand their business, which is why we take pride in having a lot of people who understand the business, and the people who do the data science have worked on a lot of food and manufacturing companies before, so they already understand the language and have good pattern recognition for what types of techniques and potential solutions are going to work. So I think that's pretty critical as well.
Excellent. So for Q&A today, the main question I think each of you have touched on already slightly, but we could explore it a little more for a couple of minutes. That's the question, we've tried this before and it didn't work. So how is it different this time?
Yeah, I mean, so as you said, it has been touched on a bit. I would say there's a couple of reasons. I mean, one, just as Sushil's mentioned, there's been a lot of changes in the theory around data science. There's a lot of technology changes too, and I think both Evan and Sushil are way more capable than me of talking to that.
I would say the principal reason for why things may not have worked before, partly lies in not being aware of all the data science tools. But sometimes it's not that. Sometimes it's using the wrong technology for the job. Being sometimes overeager on data science can also cause the same result. So you do need to balance data science with making sure it works in the real world. But there is I think the most important point is data science applications, they are different. They're different from the classical enterprise applications. In order for them to succeed, you need a lot more flexibility in how you build them, what platforms you use to build them, and also your business processes, your implementation processes need to be a lot more flexible. In that, for example, a sort of a net forecasting model is always different from company to company. How they want to forecast may be different from how somebody else wants to forecast. And also the data sets they have access to may be different from what somebody else has access to. So you have to make it work for that company. So that means you need flexibility and so on. So the traditional ERP companies and early SaaS companies as well focused on standardization, wanted the same exact model to work for everyone. And I think that doesn't really work. So part of our sort of, Simon and I founded this company and was to move away from that paradigm and build flexibility right into our business processes, implementation processes, and technologies we are using to build all this. And I think that's one of the reasons we have an extremely high customer success rate. So I'd like to mention that too.
Yeah.
I mean, that's the whole thing, is to make sure that we're building that flexible solution that works for the specific customer that we're dealing with at the time. I think the data in the data in question, is the data good quality? Can we help fix that if it's not? That's a place where we've put in a lot of effort, not just from the data science team, but from the data engineering team and all of our other team members. So making sure that we have clean data to work with, making sure that we are solving the problems that the people on the ground are asking. The executives have a great idea, the great vision at the high end, and we need to solve those problems. We also need to solve the problems that the planners are working on, schedulers are working on.
Yeah.
We need to solve those problems at all those levels to add value to our customers. And I think that focus and that targeted approach, I think, is the key to getting a successful customer. And that's how I think we would work. We work well.
Yeah.
I love it. This has been a fantastic webinar. It went by so quickly. Thank you all for agreeing to come on and host and talk about what you do. I can close out by saying, as a marketer, out of all the companies I've worked for, Austin Data Labs customers are the most enthusiastic to work with me and talk about us and share how excited they are about our product. And that is a fantastic endorsement of your data science and how well it works for everyone. So thank you. And for those watching at home or in the office, if you go to our webinar page a little later today, you'll be able to watch the recording. You'll also be emailed the recording. If you come back tomorrow, the captions will be uploaded on the recording as well, so you can watch without sound or in another language. Thank you for attending.
Thank you, Leslie.